morning of the launch, there was a total of 4 ground stations set up. 3 of them were ours. One of them was for Cal Poly, California Polytechnic University. We had 2 of our stations and the Cal Poly station at a site called X55, which is about 400 yards from the actual launch site. We had another site set up off the island on the main Wallops base, just as a backup in case anything went wrong at the main site. At the main site, we had 2 of our stations again, and the Cal Poly station. The 2 of ours, one was a high gain, one was a low gain. There was a little bit of concern about actually closing the link between the ground and the satellite and actually getting the data. So that's why we decided to go with the high gain. And then the Cal Poly station, which was operated remotely over Skype and a remote desktop link by the guys in California. We also had a station set up here in Lexington, as well as one in Moorhead, using our high gain antennas that we're going to be using to operate our satellite, KentuckySat 1. We also had several amateur radio guys track the satellite and actually give us a lot of good data. So with that, I'd like to extend my thanks to all the hams that tracked us, as well as all the guys down at Wallops for all the work that they've done in helping making this mission a success.
The main purpose of the flight this morning is to test the second stage improved Malamute sounding rocket motor. But we are also carrying 2 spacecraft that were developed by students in Kentucky and California. These are called CubeSats, which will eject at approximately 77 miles altitude, 72 seconds into the flight. The CubeSats are about 2 pounds each and 4-inch cubes. The Kentucky CubeSat, called AdamaSat, was developed by students to allow experimentation with hardware and software subsystems. They intend to fly in an orbital CubeSat called KentuckySat that will be launched with the NASA Glory mission no earlier than November of 2010. The subsystems include an antenna deployment system and power conditioning circuitry. The Cal Poly CubeSat is developed as a testbed for PolySat bus technologies and will be testing an attitude determination system. In addition, there will be several ground stations that have been set up by the students at Wallops, several sites in Kentucky, and also at the U.S. Naval Academy in Annapolis, Maryland. These are to capture the telemetry during the flight.
KSG? KSG is green.
Rock and roll.
2, 1, 0. Land your
Yeah! Second stage. Oh, yeah!
So one of the comprehensive success criteria for SOCEM was that we would receive data from AdamaSat, actually from both the payloads, but specifically from AdamaSat. And we're just looking for a packet, one of the APRS packets from AdamaSat, which would explain, because of the way we designed our packet, would explain whether the cutter's cut. It would have the information about the temperature on board the payload, and also mission time and the packet number. And right there at X55 at Wallops, at our high gain antenna station, first off, we were hearing the data come through, as you'll notice from the video, and you could hear that audio come through, but at first the packets were not coming through clear enough that the TNC could decode them. But then we did have a packet that we actually decoded on the site. That was very exciting. We were able to see that the cutters cut. We got 4 Ys that indicates all 4 cutters cut, and we also got the times and the temperatures for each of those cuts. Everything we had seen in testing on the ground, but this time actually in space.
I got audio. I got audio.
You getting packets?
It's not decoding. We got packets? Yeah!
I just get it, man. Congratulations.